Hi everyone and welcome to the webinar. We'll be starting in 5 minutes from now. Hi everyone and welcome to the webinar. We'll just be starting in another couple of minutes. Thank you.
Good afternoon, everyone, and welcome. Thank you for joining us for today's session, From Concept to Market, Deploying Eve in Real Applications. This is the fourth webinar in our Embedded Video Engine series. Our last session, Powering Performance, the hardware behind Embedded Video Engine, is now available on our YouTube channel. If you haven't seen it yet, I recommend watching for added context. I'm Vonica, your host today. Hosting with us are Gavin is our Customer Engineering Support Manager and will be acting as our moderator today. Graham Brown, CES Team Leader, with more than 15 years guiding customers and distributors through complex projects. Aaron Jones, CES Engineer, bringing over a decade of experience in designing intuitive user interfaces. A quick bit of housekeeping. We'll have a Q&A at the end, so please drop your questions into the chat anytime. If we don't get to all of them, we'll follow up by email. You can also reach us directly in the email shown. And just a note, this session is being recorded for later viewing. With that, let's get started. I'll hand things over to Graham to kick off today's discussion.
Hello everyone, I'm Graham. Let's look at our agenda. About us, a webinar recap, and the journey from design to product. We'll also look at real-world deployments and finish with a Q&A. We have a lot to cover, so let's get started.
Hi everyone, and a very warm welcome to our webinar. Before we get into the main topic today, we'll give you a short introduction to Bridgetek. Who are we and what do we do?
Bridgetek, a global semiconductor company, specializes in innovative bridging solutions, including HMI solutions and microcontrollers. We are well known for our embedded video engine graphic controller, ICs and modules, which integrate display, audio, and touch functionality into a single chip. This approach significantly reduces development time and costs for next-generation HMIs. We focus on innovative silicon solutions that enhance seamless interaction with modern technologies. Our key objective is to support engineers with feature-rich, robust, and easy-to-use product platforms. These platforms enable the creation of high-performance electronic designs with low peripheral component requirements and minimal power consumption. Our services do not restrict us only to providing IC components. We also offer customized hardware solutions, designing modules with displays and software as required. Partner with Bridgetek for your future visually impressive applications. Let's build the future together.
This is our fourth webinar in the series this year, and so we'll briefly recap the previous sessions. In webinar 1, we explained some of the key features of our Eve devices and how they enable you to create amazing HMIs and immersive user experiences for your product with minimal redesign effort and with minimal impact on your main MCU and its firmware. You can scan this QR code to visit our Bridgetek YouTube channel and play the recording. In webinar 2, we focused on the user interface development with Eve and a range of software tools which help you to do this. We demonstrated 6 of the ways that you can develop your UI design. You can scan this QR code to visit our YouTube channel and play the recording of the webinar. And in webinar 3, we moved the focus to the hardware of Eve. This includes our IC development kits that were recently introduced, including a display, an Eve module, and everything else you need to get your design up and running in minutes. And again, you can scan this QR code to visit our YouTube channel and play the recording of webinar 3. I'm now going to hand over to Aaron, who's going to give you a summary of what Eve is and how it's evolved over the different generations.
Thank you, Graham. So Eve is a graphics accelerator IC that connects to your preferred MCU via SPI or quad SPI. For the FT808 series, it also facilitates the use of I2C to communicate with the device. The display output drives LCDs using drawing and what we call coprocessor commands to create comprehensive user interfaces using inbuilt shapes, graphics effects, images, fonts, and much more. It provides touch and audio feedback, even via low power MCUs. It has a built-in LCD backlight driver support via PWM, and depending on the generation, supports onboard flash or SD cards for graphics assets such as images or fonts. The latest generation BT820 adds video input capability for advanced applications. So now we're going to cover the evolution of Eve. The first generation FT80X, introduced in 2013, was a new way to add graphical HMIs to products. Since then, each generation has expanded capabilities from higher resolutions and color depth to video playback, automotive qualification, and now the BT820 with video input. This timeline shows how Eve has steadily evolved into a powerful platform for graphics, audio, and touch integration across industries. As display sizes and resolutions grew, the FT81X series was introduced. It added higher resolution for sharper graphical user interfaces, expanded graphics memory to store assets like images and custom fonts, and improved performance for more complex HMI layouts. Eve's third generation, the BT815 and 6, was designed for asset-heavy applications and was released in 2017. This includes external flash interface for storage of large graphics assets, ASTC compression support for efficient image storage and rendering, and greater flexibility for applications which need rich visuals and branding. The fourth generation BT8178 of Eve quickly followed. This generation delivered more graphics processing power for larger, high-resolution screens, an automotive qualified version making it ideal for automotive dashboards and medical devices, and enhanced reliability for demanding environments. The BT88X generation brought the benefits of the FT81X series to smaller resolution screens, extended Eve's reach into compact devices that still require dynamic branded interfaces. It delivers the flexibility by supporting 90 degrees screen rotation, making it easier to adapt GUIs to different orientations. And finally, the fifth generation of Eve, the BT82X version, was released. This supports high-resolution screens of 1920 by 1200 and common form factors such as 15.6-inch LCDs. Changes design to a frame buffer approach and provides an LVDS instead of RGB output along with the LVDS input, which allows you to incorporate live video and real-time image processing into your application.
Thanks, Aaron. Once we've selected the right Eve family device for our application, we can get to work on our user interface design. Of course, your mission to design and deploy amazing user interfaces requires not only the right IC, but also the right tools to support your design process. And this is where our Eve emulator comes in. So let's dive in and find out more.
How am I supposed to test this coffee machine UI? I don't even have the right panel size or hardware yet.
Check out Bridgetek webinar on Eve Emulator.
Wait, they can emulate what I want? Yay! Full UI simulation on my PC.
Designing your user interface doesn't have to wait for hardware. With the Bridgetek Eve emulator, your software comes to life first. First, we pull in the display panel. The emulator mimics its every pixel and touch point perfectly. Next, the development module. All that processing power is now simulated and ready for your code. Even the accessories and cables are accounted for. The entire ecosystem is now inside your PC. And just like that, your UI appears. You can test, tweak, and perfect your design in the virtual world. While you've been perfecting the UI, your physical components have been making their way to you. Look, your display panel, module, and accessories have arrived exactly as planned. Now simply push your finished UI from the emulator directly onto the hardware. From virtual to reality, that's the power.
In this example, we'll show you how Bridgetek software tools empower you at every step of the user interface design process. We begin with a UI design for a scooter dashboard created using AI. You could also use our Eve screen editor, code examples, or many other approaches to develop the user interface for Eve. We will emulate our UI on the computer monitor first, and then proceed to preview on a real Eve module display using a USB to SPI interface. with the computer acting as a host MCU. And we'll then deploy our scooter dashboard code to the Raspberry Pi RP2040 Pico for standalone operation and integration into the final product. The Bridgetek Eve MCU Dev software library allows you to deploy a single set of application files to a wide range of target platforms, including the emulator, the USB to SPI interfaces, and a broad range of MCUs. Having a centralized main application code across all target platforms makes the code easy to develop, test, and maintain. So let's get started by downloading the Eve MCU Dev library from GitHub. We can choose the main branch, or we can also choose the development one for all of the latest editions. So we can download here as a zip file. And in the download, we have a range of examples included to help you get started. So let's take the simple one and make a copy and use it as the starting point for our dashboard. And we can rename it as Scooter for our new project. Within the folder, we have the folders for different platforms that you can deploy to. The common folder holds the main application code itself, which is used for the Scooter project for each platform. And as mentioned earlier, we'll look at the emulator, the FT4222 USB to SPI interface, and the Raspberry Pi Pico platforms. So first of all, let's try the emulator. We can open the emulator solution in Visual Studio 2022. And we can set the Eve device to BT817 and the display to match our 7-inch 800 by 480 panel. Here are the common files at the top containing the application, and here is the target-specific layer of the library, which is for the emulator in this case. Here's the main example code, which contains the simple example which we duplicated earlier. We can run it in the emulator to see the emulator in action. A window opens with our emulated BT817 display with our Bridgetek logo, a counter in custom 7-segment font, and we can use the touch with the mouse to simulate touches. So let's replace that code in Eve example.c file with our scooter dashboard code that we created using AI previously. So we can paste in the code to replace the scooter example as shown here. We can also rename the project as Scooter, just for easy identification. And if we go and run the emulator again now, we'll see our Scooter dashboard running. So you can see again the Eve screen here being emulated with a gauge in the middle there and custom font for speed readout, and a full screen background image in ESTC format. And again, we can use the mouse to indicate to replicate touches on the screen. We can now run the same application code on the real BT817, and so we go back to the Scooter folder and we can open the FT4222H platform in Visual Studio 2022. Since it uses the same Eve example code and the same platform settings, we can just run the code again to view on the real module. And we can now see the module here, the kit running the demo application, which looks exactly the same as it did on the emulator, with our gauge in the center and large custom font. And again, we can use our finger to control the touches in this case. But perhaps the speedometer indicator would look good in red instead of white. So let's go back to the emulator and try to change it. Because of Eve's object-oriented commands, we can easily change the color of our pointer via just a small code change to the color RGB command. Simply change the value from white to red, and then the gauge pointer will change color. So we can very quickly run it again to see the result of our changes and to fine-tune the color if required. And as we can see, we have the same user interface again, but now the pointer is red according to the change in our code. We could very quickly try other shades or colors and other design changes as well, and rapidly try them on the emulator. Now that we've changed it, we can also go back and see how it looks on the FT4222 project. So we can open up the project again and run it to see on the real module. And here we can see, just as per the previous change, we've now got the gauge pointer in red. So we could go back and make many other changes and try them out very quickly using the emulator and FT4222 projects. But since we're happy with the design, let's push it out to an MCU now. So again, go back to the Scooter main folder, and this time we'll have a look at the Raspberry Pi Pico folder. And we can open the workspace for our Raspberry Pi project. This opens in VS Code, which has the Raspberry Pi extension enabled. You can also build using the command line Pico tools. Once the workspace is fully opened, we can run a cmake clean followed by a compile. And as with the emulator and FT4222, we're building from the same code here, from the common folder and the same Eve platform. Once complete, the Pico tools generate a UF2 file. And we've attached the Bridgetek MM2040 module to our BT817 development kit. And if the boot select button, and the module appears as a storage device, and we can drag the file into the storage device. And just in a few seconds later, the application begins to run from the Pico independent of the computer, beginning with the calibration screen, and then following on to the main application with our red gauge pointer and looking exactly like it did with the emulator and the FT4222 platforms. We could continue to integrate our application code, which reads from real sensors on the scooter via the Pico I/O pins and controls things like headlights to produce the final product. We can, of course, go back and update and refine the design further in the emulator and FT4222 platforms, and then deploy back to the Pico. Likewise, if we decide to use a different MCU, we can deploy the code to that platform instead of the Pico. The emulator can support a wide range of display sizes and resolutions, and you can easily set them as shown here. Here we show how to set our IC development kit, IDK BT81770A, which has a BT817 and 7-inch display similar to the hardware shown. You can also set the Eve device type and display resolution as shown. Therefore, you can easily set the emulator up for your own display panel and Eve hardware by setting the values here. If your project uses Flash on the BT81X series or BT820, you can also use that too by specifying the path to your bin file, and likewise the SD card for the BT820. And so you can emulate projects which store assets in the Flash or SD card. So going back to the beginning of the process where we design the UI, here are some of the software tools that we have to help with the user interface creation. We'll just give you a brief summary here because we covered these in a lot more detail in our webinar 2, which you can find on YouTube. First of all, our Eve Screen Designer. This is a drag and drop, what you see is what you get editor, where you can add both built-in Eve widgets and custom software-defined widgets. It supports output to multiple MCUs, including the Bridgetek FT900, Raspberry Pi Pico, and STM32. The core logic is designed using a flow code style interface, making it easy to handle touch inputs and page transitions in your application. Eve Screen Editor is a drag and drop editor for designing one screen at a time. It lets you easily position UI elements and export the layout to your microcontroller. Touch handling and page switching are managed in the MCU code instead, while ESE provides the export function to generate the code, for example, like the scooter example that we showed a few minutes ago. Eve Asset Builder is a very universal tool which provides a wide range of utilities for converting images, videos, audio, fonts, and many other assets for use in your Eve application. We also have the custom touch compiler, which allows you to support other touch controllers, and you can program and build bin files for the Eve attached flash on BT81X and BT820. Our Eve code libraries are available on GitHub, and we have a wide range of libraries, including the Eve apps and the Eve MCU dev, which we used earlier for the scooter demo. These come with a wide range of downloadable examples to help you quickly learn Eve techniques and start building applications. LVGL is supported on Eve chips through our Bridgetek libraries, allowing you to reuse existing LVGL designs or to develop an LVGL if you're familiar already with it. You can download the library from our GitHub page, and we've given you more details on how to use these in webinar 2. And finally, AI-assisted development. With AI, you can accelerate your Eve projects by generating a framework code or complex custom widgets in much shorter time. The output runs directly in the Eve libraries, enabling you to quickly create dynamic, eye-catching interfaces for bespoke applications. This approach was used to generate the scooter demo, which we showed before, and it shows how AI can complement traditional workflows and help you deliver polished UIs faster. So I'm going to hand back to Aaron, and he's going to give you an insight into just a few of the many applications of Eve.
Hi everyone, I'm Aaron. Today we're exploring how intuitive user interfaces are transforming real.
Thank you, Graham. So yes, now we're going to cover some of the typical application use cases for the embedded video engine. As you can see, some of these are listed on the screen here, but we're going to go through them individually just to give you a better overview. So one of the first applications for Eve is in vehicle dashboards. For example, on the scooter, like Graham showed you earlier, Eve can generate dynamic user interfaces on a wide range of displays of different shapes and sizes to suit the form factor of the scooter, including high brightness, rugged panels for outdoor use. Here we have a carbon fiber background with a large custom gauge for the speed, along with various icons and indicators. We also use touch to control the left and right headlights here. Here's the block diagram for the scooter application. The first section of the block would be to connect MCU to your sensors. These can collect information from battery and other sensors, control items such as headlights, etc. The MCU would then process the data, interpret sensors signals before displaying information on the screen, calculate speed, monitor battery level, handle lightning, status, etc. It would then send commands to Eve. This MCU would process the data to the embedded video engine. It would use SPI or QSPI and update the dashboard visuals like the speedometer needle and battery icons as required. The display is on the LCD panel. Eve drives the screen with vibrant dynamic graphics. For this application, as Graham showed earlier, we were using the IDK BT81770A development kit. This includes a BT817 device. You can also use this development kit for developing for the automotive qualified version of the BT817A, and it's bundled with an 800 by 480 pixel display, but is fully capable of driving larger display panels if needed. For example, there is a 10.1 inch BT817 development kit, the IDK BT817101A, and this has a WSVGA screen, which is 1020 by 600. And it offers the automotive qualified version offers extended temperature range of -40 to 105 degrees Celsius. So the next application is for example, another car dashboard. And here we demonstrate the powerful graphics capabilities of the BT817 and its automotive qualified version, the BT817A, and driving a large number of dynamic gauges and indicators simultaneously on the screen. The highly customized dashboard includes widgets for speed, fuel, boost, brake wear, tire speed, or gear selection, and many more. All these are refreshed quickly through simple SPY commands to the BT817. Instead of the MCU worrying about how to draw each gauge or fill every line, we send object-oriented commands and leave the calculations and rendering for the position of these items and their fills, etc. up to Eve. This makes it an efficient way to drive highly active displays that need continuous updates. The ideal module for this example is our IDM 2040-7A module, which includes a Raspberry Pi RP2040 MCU and multiple external interfaces such as I2C. For example, we can connect our engine sensors and brake wear indicators to our MCU over CAN bus as well. And then we can take all of this information and update the screen with our dynamic gauges using the BT817 or BT817A, where Eve handles all of the graphics rendering for us. We can optionally use the touch and audio generation if required by the application, but this dashboard application does not require touch, so it is not included. The next example we have is an HVAC or smart meter HMI. Eve is ideal for smart home applications such as these. With Eve, you can show sensor readouts such as temperature and fan speed, and even add multiple pages for extra information. Here we use an arc gauge to represent the temperature, and the on-screen touch buttons avoid the need for mechanical switches around the display. We can easily add audio tones using Eve's audio synthesizer to acknowledge touch, and we give the buttons a pressed-in appearance when touched. Large custom fonts ensure the main temperature readout is easily visible and improve the aesthetics or branding of the application. So in this setup, the Eve chip is the FT81X, and this drives the display, handling output, touch input, and audio like a beep when one of the buttons is pressed. The MCU sends commands to update the screen and reads registers from Eve to detect touch inputs. Thanks to Eve's touch tagging feature, each button can be tagged with a number. For example, the plus button we've tagged with 100 and the minus button we've tagged with 101. The MCU simply checks the reg touch tag register, and if it reads back a value of 100, we know that the up button was pressed and we can update the screen accordingly. This offloads complex HMI tasks from the MCU, letting it focus on its main job, such as communicating with a Zigbee radio module to control the HVAC system and turn fans on and off, or give you cold or warm air, whatever is desired by the application. So remote operated vehicles are used as another application, and these are used for underwater inspection applications and often rely on a monitor to view the camera on the ROV, along with a range of gauges for parameters such as depth, position, and thruster status, as well as mechanical controls for the lights. With the BT820, we can combine all of this into a large HD display panel, such as a 10.1 or 15.6 inch display, up to resolutions of 1920 by 1200. The BT820's live video input allows us to use the live camera feed from the ROV to be displayed without passing through the MCU as a full or partial screen overlay. In this instance, we're using a full camera feed and overlaying gauges on top. Bespoke indicators for heading can be smoothly animated on top of the live video engine, as you can see here, as well as touch controls for the lights, for example. The BT820's powerful graphics engine handles the scaling, rotating, and blending of images without complex calculations on the MCU. So we have real-time video processing if required, again offloaded from the MCU, and Eve handles that for you. Here we also use touch tagging and tracking features to implement the buttons and sliders on the screen. For these applications, Eve can add useful widgets as well, like a compass or depth indicator. Here's the block diagram, and the MCU handles the main control signals for the submarine or ROV, controlling motors and lights, for example, and reading back sensor data, while Eve takes care of the graphics rendering on the control panel for you. The video is converted to LVDS and goes directly into the BT820 here, as opposed to being fed through the MCU and onto the display. This means that the MCU focuses on sending operator commands, and Eve ensures the dashboard stays dynamic, responsive, and visually clear. Eve is ideal for other applications, such as medical applications. We have two on the screen here. This is a pulse oximeter demo and a bedside patient monitoring demo powered by Eve. What makes Eve stand out is its ability to handle live data and scrolling graphs, perfect for sensor inputs that need real-time visualization. Whether it's oxygen levels, heart rate, or patient monitoring, Eve updates the display smoothly and keeps information clear for users. This shows us how Eve can bring dynamic, responsive interfaces to medical devices, making them more reliable and user-friendly. Eve can support small displays for personal medical devices, such as the pulse oximeter, and large displays for patient monitors, for example. So here is the pulse oximeter block diagram. The pulse oximeter uses our IDM 2040-43A development module. On board, there's an RP2040 MCU, which we have connected to the pulse oximeter sensor over I2C. The MCU reads live sensor data over I2C and can control the LED light on the pulse oximeter sensor. It processes the data on the MCU and averages out or filters our raw data for us so we can then display it on the screen. The MCU then sends commands to Eve to update the BT883 embedded video engine over SPI to update our graphs and widgets on the screen. For example, we have an ARC widget here to give us our current SPO2 level. It's looking good at 98 on this the screenshot, but 96 on the video, so might be on the edge there. But then the Eve renders the graphics for us, showing a scrolling graph of the live LED readings and updates the ARC widget with our current oxygen level. Touch is also enabled on this demonstration for a small settings menu, allowing us to rotate the screen if desired and turn on and off an audio beep, which is also incorporated into this example using Eve's inbuilt audio synthesizer. The patient monitor demo. This demo uses a Raspberry Pi RP2040 MCU with the live patient data like heartbeat and blood pressure being displayed on the screen. Eve handles scrolling graphs, touch, and audio while the MCU workload stays light. Assets such as branding can be stored on a flash or attached SD card on the BT820 and rendered directly with Eve via simple commands. The kit used for this was the VM820B15A, and it provides a 1920 by 1080 display and BT820 graphics accelerator along with an onboard MCU. You can attach the MCU, much like the previous example, to the RP2040, which will then process any sensor inputs, and the MCU can then decide to update the screen if required with scrolling plot data. This example also includes touch and sound. You can see there's some buttons on the screen to activate these. Eve is perfect for coffee and vending machine menus as well, showing options like an Americano or a cappuccino, or my preference a flat white, with branded user interfaces. Brings significant benefits for both user experience and marketing, as products can be represented by graphical icons instead of code or mechanical buttons. Prices and descriptions are easily updated, and out of stock or unavailable options can be easily identified to the user. Provides a clear indication of machine status and keeps users informed as to the options available. It can also indicate clear error messages when something needs attention on the screen, for example, refilling the coffee beans. Maintenance and sales history menus allow the machine to be easily serviced through the same display. So here's the block diagram of the coffee machine application. The MCU handles sensors such as heaters, pumps, grinders, etc., and even payment systems, RFID or 4G modems if required in your payment system. Meanwhile, Eve takes care of the graphics rendered on the screen, so the MCU can focus on control tasks while display stays dynamic and engaging. Touch input is simple. The MCU reads Eve's tag registers or uses the interrupt pin to detect selections. For example, pressing cappuccino triggers the MCU to run the program that sets the milk levels and grinds beans as required for a cappuccino. Using modules like the BT817 development kits, you can also attach flash storage for your company's assets. This makes Eve ideal not only for copy and vending machines, but also for industrial HMIs where responsive branded displays are needed. We've covered applications here, and I will pass it back to Graham to round up this webinar.
Thanks, Aaron. So thank you for joining us today for this webinar. As we've shown, our embedded video engine makes it easy to add eye-catching and dynamic user interfaces to your product with minimal development time and redesign effort. With our Eve emulator, we've added another powerful tool to the Eve design flow. It allows you to rapidly develop, test, fine-tune, and demonstrate your user interface. We've also given you an insight into just some of the many applications of our Eve devices. Of course, there are many, many more too, and so please get in touch to discuss your requirements with us. Overall, we don't have to make the difficult choice between creating amazing user interfaces and time to market. With Eve, you can have both. So thank you again, and we look forward to working with you on your projects. And it's now time for our Q&A session, so I'll hand over to Gavin.
Hi everyone, I'm Gavin, your moderator for today's session. I'm keeping an eye on the Q&A box right now, so please keep those great questions.
Thanks, Graham. Yes, so it's now time for the Q&A. If you have any questions, please add them to our chat box and we will get back to you. If we don't have time today, we will get back to you by email. While we're waiting some questions, I want to let you know if you subscribe to our newsletter, you'll be up to date for any of our future webinars. Okay, to keep the ball rolling, I'll start off with a question. Can the emulator also simulate the audio features of Eve?
Yes, it can. It fully emulates all the features of Eve, including the audio synthesizer, and will output any audio tones that are inbuilt into Eve or custom audio files which you may have included in your application to play back via your PC's speakers.
Thank you, Aaron. And we have a question from Rudolph. Tried the emulator today, will add a target to my library. As a bare minimum, this should be great for screenshots and sharing UIs with the team.
Excellent. That's good to hear, Rudolph. Yep.
Yeah, I actually do use it for screenshots quite often because they come out quite nice.
Absolutely, especially for making presentations like this. While we're waiting questions, another thing I want to mention is this is number 4 in the webinar series, and all 3 are live on our YouTube, and you can scan the QR codes and you'll be able to watch them. And similarly, we'll be putting out today's webinar on our YouTube and we'll let you know. Okay, another question. You showed a demo of a patient monitor. How do we draw the charts that are used in this application?
Oh yeah, I think that's our MedInfo demo, which is available from our GitHub page under the Eve MCU Dev Library. So when you're using the BT820, we have a range of extensions available which you can load, and they provide additional functions such as graph drawing and other useful features like a 7-segment font display that you can use. So if we have an application note available on that and which describes the extensions, we can include the list in our email after the event. And if you go in there, you'll find some really useful extensions you can add to make it easy to draw dynamic scrolling charts and many other useful widgets.
Okay, thank you. A question from Austin. Is rotation handled by the emulator too? So all elements will be rotated as well?
I think, is that?
Yeah, the current Eve MCU dev port of the emulator does not handle screen rotation. But so just to explain briefly, the Eve emulator is a DLL, and you can include this into your library if you required. It's on the list for us to include as a feature in the MCU dev implementation of it. But it does provide functions that allow you to rotate the screen. So we just need to update the backend code slightly to allow for this. But there are function calls in the emulator DLL which allow you to rotate the screen and do all of the other features that are supported on the Eve ICs, such as audio, which was already mentioned, and touch input, etc. So it will. The emulator itself, which is a standalone DLL and .lib file, which you can download off of our GitHub, will allow you to, yes, rotate the screen if required in your application.
Thank you, Aaron. We've still got time if anybody else has got another question. You mentioned the flash can be used in the emulator. Can the SD card also be used for the BT820?
Yes, similar to the flash, you can attach a SD card to the emulator instance, and this will allow you to access any assets which you might have stored, you want to store on an SD card. For example, in the Eve MCU dev implementation, we allow the attaching of a folder which represents the files on your SD card. Similar to what I just mentioned previously, the emulator DLL also allows the functionality to support SD card images directly as well. We haven't implemented that because we find in MCU dev it's easier just to create a folder, call that SD card folder or whatever the name happens to be, and put all your assets in there, and then that will be attached in the emulator projects. But again, there's multiple options in the DLL for supporting of the Eve features. One of those is you can attach an SD card folder, or you can attach an SD card image, just whatever is preferable if you wish to implement that in your own library, or if it's in Eve MCU dev, we have implemented the SD card folder approach. But yes, that fully allows you to support SD cards and flash binary images in emulated projects.
Thank you, Aaron. Don't think we've got any more questions. Anybody got one more?
I think just to mention while we're waiting as well,
Yes.
if anyone hasn't visited our Bridgetek YouTube channel, we encourage you to visit. We've been adding lots of good videos on Eve techniques, and we've got lots of plans for new videos showing you how to use the tools and features on Eve. So we encourage you to visit, and thanks to everyone who's subscribed already. But hopefully you'll find some interesting videos there if you'd like to visit us.
Thank you, Graham. Okay, I think we'll wrap it up. Just want to thank everybody, Graham and Aaron and Vonica, and thank everybody for attending. Thank you for your time. Goodbye.
Thank you.
Thank you. Goodbye.